Current electricity numerical, March 2017. When two resistors are connected in series with a cell of EMF 2 volt and a negligible internal resistance, a current of 2 by 5 ampere flows in the circuit. When the resistors are connected in parallel, the main current is 5 by 3 ampere. Calculate the resistances. Here, when resistors in series, the effective resistance Rs is equals to R1 plus R2. And current in the circuit is given by the expression I subscript S. Means when resistors are in series, the main current in the circuit I subscript S is equals to E, that is EMF of the cell, divided by Rs, that is effective resistance of external resistor, plus small r, that is the internal resistance of the cell. But we are given that internal resistance of the cell is negligible. Here, a negligible internal resistance. And therefore, we can take small r is equal to 0, and this equation can be written like this: I subscript S is equals to E divided by Rs. To take this Rs left hand side, that Rs is equals to 2 divided by I subscript S. Here, what is that 2? 2 is EMF of the cell. We are given that the EMF of the cell is 2 volt. Here, that is 2 divided by Is. What is that I subscript S? That is the 2 by 5 ampere when resistors are connected in series. The current in the circuit is 2 by 5 ampere. Therefore, I subscript S is equals to, that is 2 by 5. Here 2 divided by 2 by 5. And this 5 is in denominator goes to numerator. And 2 to cancel, that Rs is equals to 5 ohm. Now Rs is equal to 5 ohm, that implies R1 plus R2 is equal to 5 ohm. That's our first equation. When resistors in parallel, the effective resistance Rp is equals to R1 into R2 divided by R1 plus R2. The main current in the circuit is given by I subscript P is equals to E divided by Rp plus small r. Now small r is 0, that internal resistance of the cell is negligible, and Ip is equals to, we can write E divided by Rp. Let's write it like this: Rp na take it left side. Now you can write Rp is equals to E divided by I subscript P. Here Rp is equals to, what is E? E is EMF of the cell, that is 2 volt. What is Ip? Ip is current in the circuit when resistors are connected in parallel. Here we are given that when resistors are connected in parallel, the main current in the circuit is 5 by 3. And therefore, here instead of Ip we'll write a 5 by 3. Now 2, this 3 is in denominators goes to numerator. 2 into 3 divided by 5, that's equals to 6 by 5 ohm. What is that? Rp is equals to. Now let's write it like this. What is Rp? Rp is effective resistance of a resistors when connected in parallel. Then Rp, R1 into R2 divided by R1 plus R2, that's whatever Rp, that's equals to 6 by 5. And here R1 plus R2 is 5, and therefore R1 into R2 is equals to 6. That is our second equation. And by using a relation, we'll use the relation. You can write it like this: A minus B whole square is equals to A plus B whole square minus 4AB. Or if you elaborate it, you will get that a minus b whole square is equal to a square plus b square minus 2ab. Now you can write it like this: a minus b whole square is equal to a plus b whole square minus 4ab. And using that relation, r minus r1 minus r2 whole square is equals to r1 plus r2 whole square minus 4r1 into r2. Here r1 minus r2 whole square is equal to, what is r1 plus r2? That is 5 is a 5 square minus 4. What is r1 into r2? Here r1 into r2 is 6 and r1 plus r2 is 5. We know that r1 plus r2 is 5 from first equation and r1 into r2 is 6. Therefore r1 plus r2, that is 5 square minus 4 into r1 into r2 is 6. Now that r1 minus r2 whole square is equals to 5 square, that's 25, minus 24 is equals to 1. Taking square root, r1 minus r2 is equals to 1. Now that is our third equation. Solving equation 1 and 3, that is equation 1 says that r1 plus r2 is equal to 5 and equation 3 says that r1 minus r2 is equal to 1. When you solve, r1 plus r2 is equal to 5, r1 minus r2 is equal to 6. Here r2 get cancelled. Now it is 2r1 is equals to 6. Therefore r1 is equal to 3 ohm. And using the relation, that is r1 plus r2 is equal to 5 ohm, substitute r1 is equal to 3 here, and on simplification you will get r2 is equals to 2 ohm, and here r1 is equal to 3 ohm and r2 is equals to 2 ohm.